Okay, so today we're going to talk about constructors and encapsulation. The reason why we are, talking about both topics in the same video, it's not like they are the same, but there are one kind of effect coming from using constructors and encapsulation that are it's both can give our code the same effect. I'm going to talk about valid state. It's really important in object-oriented programming. So let's get started. And you can see valid state. First of all, an object. It's supposed to be an abstraction, right? I really want to use my car without needing to know the internal details. That's one of the most, the power of abstraction, be it a function, be it an object or anything. That's the point, actually. But also, it's really important that an object should always be in valid state. It would be weird if the ignition on the car, I have turned it off, but still the radio can be on. That would be weird. Actually, it's not that weird because most cars work that way. Let's find something else. You can't drive if it's not. Some things are just invalid. And let's forget about cars. I'm not good at cars, as you can probably hear from what I'm saying. Let's talk about hockey players. I do know hockey players. And let's say we have a class player and we have an instance, an object called foppa. And we might be able to say foppa.h equals to -51. Now the object foppa is not in valid state. So valid state is about, just listen to the word valid state. It's about validation and ensuring that all the properties are valid and reasonable. And actually, we do have two problems here. The first one is this, because after the first line, even after the first line, we can kind of agree that after the second line, the object is in an invalid state, but it also in an invalid state after the first line. We haven't set the age, so how old is he? We have no idea. Is he 0 or whatever? So so we will solve it by encapsulation. This one we will solve by encapsulation, and this one we will solve with constructors and constructor parameters. Okay, because the reason why we're doing this is we can't put the programming using the class should not be blamed. I just used the class player, Lisa says, and she shouldn't need to know the internal details and everything, and she shouldn't need to know what are valid values. John, who coded the player class, it's his responsibility to create a class that is almost impossible to misuse. So that's the point. And how can we create such classes? So first of all, we have the access modifiers. So far we have I have mentioned all three of them. So there is okay, so this is protected. That was stupid of me. I should have made it private. I typically use private, but I mean there is protected, and I was gonna say we're not looking into protected until we get to use inheritance. But let me fix it. This makes more sense, I think. Yeah. So okay, so we have private variables, and these are not. We are not able to access these variables from the outside, so we can't type player.h. And as you can see here, we use some kind of weird postfix. I usually don't use that, but you're free to use. I mean, to kind of mark your variable so you can see, okay, this is a member variable. So it's, some people like it, some people don't. I actually don't, but I want to show you there are more than one, you know, way to do things. Okay. Okay, so we have private variables. They are not accessible from the outside. So let's have a look. I mean, let's go to the code. Okay, so this is person instead. So we have a person, and it has a string, and it has a personal number. And when we create a person, it's not possible to get to the name and the personal number properties because they are private. So let me show you. If I forget about this, actually we have created a person called p dot, and you can see we are not able to set the name to something because it is private. And if I would like to set that value, I would need to, actually we should look at this. Yeah, here's a player. This is what we're going to look at. Okay, so let's do the player instead. So we have the player here, right? Okay, so we have the player, and we couldn't do player dot h or player dot name or player dot team. We can't reach them because they are protected. Copy and paste. I mean, they are private. Okay, and I mean it's not completely certain that I had made a mistake when I said protected. It does make sense if, you know, I mean, if we want to avoid that someone inherits from our class. But anyway, we have the player then, and to set values we need to write getters and setters instead. So here we have a function called setH, and if we want to, I mean, if we want to print, the h. I can't even reach it. Okay, so now I know. Okay, I want to see out the player h, and like this, and as you can see, it's not possible. It says it has no member h. Actually, it's called h underscore or whatever it was. It's inaccessible, and we want it like that because I mean, all the things in your car are. I mean, they are hidden from you. So you can't poke here and there as you like, and that's a good thing, probably. At least if you know as much about cars as I do. So when we have the need to expose something, we expose it. But the default should be, every time you create a class, always create your member variables as private. And then when you are proven wrong, you need to expose the age. Okay, let's write the function then. Call getAge. And I mean, it will be really simple. I mean, it will just, this is all it will do in this case. Sorry, can't do void, it should be int, I guess. So here, whenever we need something, we add it to the class, so it's kind of safe by default, if you know what I mean. It's as close as possible by default, and then we open up when we are proven wrong. So we need a certain value outside, so we still can't do .h. We need to call the function, because the thing is also about functions. I mean, a function gives us we have the possibility to write code in a function, right? I mean, if we do like this, a simple assignment, there is no code. I mean, we can't do any validation or anything. We just set 12 to the I. But I mean, if we have a function set I, then we could inside the function we can write code. So that's one thing that we use to ensure that we are in valid state. Let's have a look at the function. Actually, I will say he's 51, and then we will try to say that he is set age minus 12 or whatever. Okay, so I mean, we are not just setting properties, we are calling a function. And in this function, let's have a look. What happens here? Set age. Okay, so there is an age, an int coming in, and we have an if statement. Just that easy. I mean, what we do is we check if the age is less than 0 or whatever validation we want to do, and we throw an exception if it's wrong, and if it's okay, we set the value. As you can see, and this is fine. This is fine. I mean, it's a lot better to throw an exception than to allow to set the value which is setting our object into an invalid state. Because when things are in an invalid state, that's when weird and dangerous things can happen. I mean, it wouldn't be so funny for you if this wasn't a player, it was an employee, and your employer. This is the salary system for your employer, and they had maybe forgot to do the validation, and somewhere in the code, I mean, they set your age to -1 or anything, an invalid value, but it still continues, and then when the salary is paid, maybe you don't get the correct salary or something. So I mean, it's much better to crash. It's much better to crash, to throw an exception. So that's the mindset we should have when creating classes. So that's what I mean. I mean, it is not Lisa's fault. Lisa is not to blame. John is to blame, because he hasn't created the class foolproof. So I mean, it's just a few lines of code, but when you start thinking in these terms, that your classes should always be in a valid state, things will get a lot easier in the long run, I promise you. Okay, so the next thing then, I mean, this will crash, yeah. But John is fine with that, because his object is never set into an invalid state, so he has won. So now the problem is Lisa's, because Lisa is writing this code somewhere. Okay, so that's the mindset we should use, but there are more problems. I mean, it is possible. Actually, it's not, because we have the constructor. But as I was saying before we added that constructor, in the like this, it was possible to do like this, right? At least in the slide it was possible. Let me see if I can find the slide. There it is. Okay, so I mean, we did have this, yeah, we did have this example. So it was possible to create the player without without supplying the mandatory values, because whenever you have an object, there are probably a few values that are mandatory. I mean, the object would not make sense if you don't have these values. I mean, there could be, but it's not that easy. I mean, but I mean, say a salary system. You should you shouldn't be able to create an employee without a personal number or something, because otherwise you can't calculate the salary and taxes and so on. But I mean, it's in some systems, I mean, in most systems, it's possible maybe to not have a name, right? Because if you think about it in real life, it's possible to exist without a name. I mean, my youngest son did for a few weeks before we decided. So it's I mean, it's not that easy always to know what is mandatory and what is not. But we should try to use I mean, mandatory things for your object to be invalid state. We should use them as constructor parameters. Let's have a look. So now we start talking about constructors, because in a constructor, that's a special function with the same name as a class, right? It's automatically called when an object is created, and we should make parameters mandatory. And what we do in constructor is, I mean, we typically set values from the parameters, of course, but we also set, I mean, reasonable defaults. We might allocate some memory or something, and we also have the opposite called the destructor. I will talk about it in a few slides. So let's have a look. So what we're saying here, when we create the player, okay, so player, these values are mandatory. That's what I'm saying. And who is deciding? I am. But I mean, it's in conjunction with the I mean, the system and the context and so on. But I mean, here I decide that every player needs to have an age, a name, and a team. The team might be, I mean, that might be a little weird, because there are players without a team. But anyway, the thing is, we use a constructor with the required parameters, and now it's not possible to just create it like this. It's not possible. As you can see, no default constructor exists for class player, and that's a good thing, because typically because if that was possible, my point is, now the player would be in an invalid state, because we have kind of decided that all players must have an age, name, and a team. I mean, that's the business rules. it seems. I'm just making it up, you know. This is just. I mean, it's depending on the system and the context, what will be mandatory for a certain class. Okay, so we have a constructor, and as you can see, what we're doing here, we are initializing with constructor initialization list, those two. The age we are initializing by calling the function set age. And you can see the beauty here. So we have a public function which is callable from the outside to set a new age. And I mean, now from here, from the constructor, from the constructor body, we are calling that function. And the beauty of this is that we are reusing this this validation code. So I mean, it would be bad to, I hope you see, it would be bad to do it like this. Actually, to do it like this. This would be bad, of course, because now we have duplicated our code. So a constructor, it's just a function, and in a function we can call other functions. That's it. Okay. Yeah, I think that was what I wanted to talk about. Okay, so let's move on to the person then. So here we have the class person. We have a name and a personal number. And what I want to show you is, okay, so here it seems like the personal number is mandatory. And what we do in this code, as you can see now, I'm initializing it. Sorry, this is wrong again. Like this, of course. Okay, we are setting the value, of course. So what we're doing inside a constructor, be it in the constructor initialization list or in the body, we are setting the values from the parameters, and we are setting reasonable defaults. As you can see, this is not needed because a string is empty by default, but I wanted to show you a reasonable default. So this line is not needed, but I wanted to show you this comment, reasonable default. So that's what we do in the body, in the constructor. It's possible to use multiple constructors. And there are, of course, different ways of creating a certain thing. It could be, so we have a circle. In this example, it should be possible to create a circle from a radius. And it also seems it should be possible to create a circle from another circle. It also looks like it should be possible to have the circle read its values from a file. It could also be, from a database or something like that. And in our example, where we're using person, I have now added two constructors. And as you can see, a person number, since we have them in both, the personal number will be, it's still mandatory, of course. You need to use one of these. So this is the concept is known as constructor overloading, but it's just like function overloading, because a constructor is just a function. All right, so let's have a look. This means, so we have two constructors here. We have a few more already. I will talk about them in a minute. So we have the person with the personal number, we have person number, and name. So it's possible to create person in two ways. So we could either create like this, and just send in the personal number, or we could create it with 2 parameters. And depending on 1 or 2, the first or the other will be called. I want to show you, just as we did with the set age. It's kind of the same, but not. As you can see, there are probably, there is a risk of duplicating our code if we have multiple constructors, and we don't want to duplicate any code at all. So what we can do is we can call another function. This is called another constructor. This is called Delegating Constructors. So let's have a look at this. So let's talk about this one. So here we have the constructor, and we are just initializing the values from these parameters. Great. We're not doing any validation or anything. But as you can see, if we call the constructor only using the personal number, not the name, as you can see, I'm hopeless today. This constructor will be called, right? Actually, it would work anyway, because this would be empty. But this was the point. So we are calling another function and sending in person number as person number and empty as name. And this will, as you can see, we are reusing the code. I will fix this here as well. So yeah, okay, great. So that's delegating constructors, and we do it to save code. And I mean, it's might not be each and every day, especially in the beginning, where you're faced with needing multiple constructors. But when you do, I mean, a constructor is just another function, and they should be treated like any other function, any other code you do. You should never duplicate your code. Don't repeat yourself dry. All right. Okay, so let's talk a little about some other things. And I'm saying we also maybe need some extra things. Because, right, okay, so actually I jumped one slide too far. Special constructors. So there are some special constructors. There are copy constructors and there are move constructors. I will at least talk about copy constructor, but this is also, I mean, this is probably not needed if you are, I mean, if you're programming I mean, kind of a everyday line of business application, it won't be needed. But when you do start to do some own resource handling or allocating memory on your own, you might need the copy constructor. Sorry, here we are. So I mean, this copy constructor, you will get a default copy constructor, and it will work fine most of the time. But remember, it will do a shallow copy. So I mean, it will only copy the bytes inside. Actually, the string will understand and work correctly. But I mean, if we have something like a pointer, and we somehow allocate that to an array or something on the heap, this would mean that when the default constructor does a shallow copy, it will only copy these bytes. It won't copy these bytes, so to speak. So there will be now there will be two things pointing to the two objects pointing to the same, and that will be a problem later when we delete and so on. But I mean, this is not that. I mean, it's not used that much because we seldom dynamically allocate memory and resources. We try to avoid it. I mean, we try to use classes, and the classes itself might do allocations, but they also can do move and copy constructors by themselves. Anyway, so if this, I mean, I want to show you. So this is a copy constructor. So we do the const, we have the person and reference to other. And what we do is we call the constructor sending in the person number and the name from the other. And then we have a copy. So I mean, this would work just without, it would be the same result even if we deleted this. This will only come into play and make a difference when we dynamically allocate some memory and resources. When is this called anyway? It will be called when we do like this. So we create a new person and we assign it in the same. That is actually a one-liner which will call the person copy constructor. Also here it will be called. Okay, so we might also need the copy assignment. So this, sorry for this font, it was not that nice. Let me just, sorry, how could I miss that? All right, I think it's better. Okay, so we could also create a copy assignment, and that's an operator overload. So as you can see, we always return sorry, I'm not doing that. Stupid me. So in this example, it would actually work anyway, because we are not doing anything more, but if we would change things after each other. So it should be like this. It should look like this. I'm sorry. So this is the copy assignment. And it will be called when we already have an object and we later assign it to another object. So as you can see, we have an object and we assign it to another object. I hope you see the difference. Here, we don't have the object. So we are creating the object at the same time as we are assigning it. Then the copy constructor will be called. And in this case, we already have an object. So there is no constructor being called, but instead the assignment is being called. But once again, this will just work fine. This will work perfectly fine if without these functions. So you don't have to create these functions. I will talk about it more in detail later. You might also need a destructor. So that's when you have during the lifetime, often in your constructor, if you dynamically allocate something, you need to ensure it's deleted and removed and freed to this return to the system, and you do that in a special function called the destructor. So this is the destructor mark, or should I say. And it's called automatically when an object goes out of scope. So as you can see, it's really, I mean, there are kind of hooks. See them as, so it's possible to inject some code whenever an object is being created and when it goes out of scope, that is being deleted. And we use these to, pretty much to ensure we are in valid state. And also we allocate memories, and in the destructor we return the resources to the system. Okay, that's all for today. Thank you.